All right, this will be the last lesson until we have a little quiz. So let's pay attention and make sure we understand everything that we've went over so far. This is called the special role of zero in factoring. So let's see how we set all these equal to zero and find our, you'll hear them called zeros, roots. They'll end up being intercepts later on. I can't think of what I would call them, but right now you need to know them as zeros. Find all solutions to the equation x squared plus 5x plus 6 times x squared minus 3x minus 4. Okay, so that's what we want to do. The easiest thing, you don't want to distribute these polynomials. We want to factor them. So for this first one, this should factor into x plus 2 and x plus 3. Second one should factor x minus 4 and x plus 1. So if you were to full that, you should get those two polynomials there. Okay, so what happens when you find zeros, you set each one of these equal to 0. So x plus 2 equals 0. Well, let's subtract 2, x equals -2. So if you notice, all you're going to do is change the sign for all of these. So x is going to be -2, -3, +4, and -1. So all the zeros, if you set each one of those binomials equal to 0, that's what it will equal. And you know that you say 4 minus 4 is 0. So +4, +4. Might find the solutions of them. They're called solutions, called zeros, or called roots. Once again, we want to factor out these binomials here. Hopefully you looked at these and saw that these are absolutely going to be difference of 2 squares. So this difference of 2 squares is conjugates. So we have 2 sets of conjugates. The first one's going to be x and 3. So it's going to be x and 3, x and 4, x and 4. Now, if you were to answer these, once again, you would just change the signs. So your zeros would be 3, -3, 4, and -4. Now, let me show you a trick. If you take these binomials that we have, let's say x minus 4, I'm sorry, x squared minus 9 equals 0. Well, x squared is equal to 9 when we add 9 to both sides. We take the square roots. X is equal to, anytime you square root something, that is always plus or minus that number, because -3 times -3 is 9. 3 times 3 is 9. So it's plus or minus. So we have plus or minus 3. Well, look, our answer is plus or minus 3 there. And it would work for x squared minus 16 again. So if you get it down to a binomial, you should be able to find these zeros. Now, suppose that we know that the polynomial for the x cubed minus 12x squared plus 3x plus 5 is equal to 0 has 3 real solutions. And that one of the factors of that is x minus 1. How can we find all 3 solutions given this equation? So here's the thing. You always know that there's going to be 3 solutions because the highest degree is 3 here. Now, if we know that one of them is already x minus 1, then we know that one of the solutions is going to be 1. Now, if we were to set x minus 1 equal to 0, that would equal 1. So now then, I'm going to I'll go ahead and do long division. I was going to do the box, but let's do long division. We can do this because we already have one of the terms. So how do I get x to be 4x cubed? I need 4x squared. That's 4x cubed and negative 4x squared. And I negate those. I get negative 8x squared plus 3x. I need negative 8x. It's negative 8x squared plus 8x. That cancels and leaves me with negative 5x plus 5. So I'm negative 5. And yep, it all works out. Negative 5x plus 5. Negate those. And that cancels everything out. So now then we have 4x squared minus 8x minus 5. So now I still, what can I do? I still don't have binomials. I can set equal 0. I'm definitely not going to try and set that equal 0, but I still factor. I can actually factor those. Let's see, 2x and 2x gives me 4x squared. What can I multiply together that I also add outer and inner to get the middle term? Minus 5 and plus 1. That work out, ends up negative 10x. Yep, plus 2x is equal to negative 5 or negative 8x. So I would set those equal to 0. Now, what happens when I say 2x minus 5 equals 0? Add 5, add 5, those cancel. 2x equals 5. Well, x is not by itself yet, but I have to divide by 2. So x is equal to 5 over 2. So we can write that up here, 5 over 2. 5 over 2. Now let's find another little spot here. Okay, I'm going to go over here and do 2x plus 1 equals 0. 2x equals negative 1. Divide by 2. Divide by 2. X equals a negative 1/2. The other term will be negative 1/2. There's all 3 of the terms, or all 3 of the solutions. Which means is if I plug that into that, if I plug those in for x, I'm going to get 0. That will give me 0 into this polynomial. All right, let's see here. Find the zeros of the following polynomials with their multiplicity. So multiplicity just simply means if a 0 occurs more than once, how many times does it occur? Okay, so I'll show you here. So here we have, you can take this, that's going to be negative 1, just take the opposite. This is going to be 1. And then this one's going to be plus or minus 1. Because when you square root it, remember, you have plus or minus 1. So the way I would write that is I would say we have 1, 2, negative 1. So let's say negative 1 with a multiplicity of 2. Let's I can't remember how we actually write that. Let's just call it multiplicity, negative 1 multiplicity 2. And then we'd have 1 multiplicity 2. Okay. Now, g of x, oh, these are the much easier ones. So this one tells you that you're going to have, if you set that equal to 0, that's going to be 4 And you're going to have that with a multiplicity of 3 times because it happens 3 times. That's x minus 4, x minus 4, x minus 4. So for this one, we're going to have 2 with a multiplicity of 8. It's going to happen 8 times. So 2m8, something like that, let us know that you're talking about 2 with a multiplicity of 8. So here 2x minus 3 equals 0. 2x equals 3 divided by 2. So x is equal to 3 over 2 with a multiplicity of 5. It's going to happen 5 times. Also, that is our degree there. Yeah, this one's still nothing hard about it. Don't care if there's 100 in the exponent or not. That's equal to 0. So we have 3x minus is equal to negative 4 divided by 3 divided by 3. So x is equal to negative 4/3 with a multiplicity of 100. All right, we'll still got to do the other one, which the other one's easy because it's 17 with a multiplicity of 4. What else we got here? Find a polynomial function that has the following zeros and multiplicity. What is the degree of your polynomial? Okay. So we need a 0 2. So we say x minus 2. That's going to give us a 0 2 because it's a multiplicity of 3. X is plus 4 to give us a 0 of negative 4. And that's just to the 1. So we'll go ahead and put the 1 up there. And then x minus 6 gives us a 0 of 6 to the 6th power. It gives us multiplicity of 6. Then we're going to have x plus 8 to give us a 0 of negative 8 to the 10th. Oh, sorry, guys. I was trying to pause it real quick before that happened. Okay. So x plus 8 gives us a 0, negative 8 to multiplicity of 10. Now, here's the kicker. Normally we say, look, tell me what the highest degree is, and that is your degree. But that's when you're having like a binomial or trinomial where they're adding. These are all multiplied together. So you're going to add the exponents together to get your degree. So that would be a degree of 20. Okay. Now, is there more than one polynomial function that has the same zeros and multiplicities as one of your as the one you found in exercise 3? So what is that asking? Let me see here. Is there more than one polynomial function that has the same? Okay, so what that's saying is, could there be the same zeros in another polynomial? And the example that's given, I think, would be something like x squared plus 5. Where you're really not going to have a real number. Because there's no square root of 5. I mean, there is a square root of 5, but it's probably going to be an irrational number because it's just going to go on forever. So let me check. Square root a 5. Yeah, it's just going to go on 2.23606797775, blah, 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 probably. So that would mean that there's going to be a no solution. So we could write that and then just do all these other ones that have to make it have the same. So it's got the same zeros, but the whole thing is going to be messed up by this one term. And so there would be no real solution for that one. So yeah, I guess you could. You would have real solutions, real zeros for all of these, but this would be a no real solution on that one. Okay. And then it's, whoa, what's going on here? What's going on here? Oh, I'll give you like a vocabulary terms here to figure out. Or not figure out, but to make sure you know, kind of review for all those zeros or roots of a function. I went over that. Okay. Can you find a rule that relates the multiplicities of zeros to the degree of the polynomials? Yeah, so it's the sum of the multiplicities. That's the degrees of the polynomial, like I said earlier. So if you have x plus 2 to the 4th and x plus 7 to the 3rd, then the degrees are the sums of the degrees of polynomials. You just got to add them up. That's because they're all multiplied together, so we're going to add the exponents. That's probably it for your homework. So if you got that, be ready to come in and work on your lesson tomorrow, and you should be good. And then we will do a review for your quiz.